wherever the downstream system is, it's going to get only the data that it needs, right? So that can help us control the cost.
That's interesting.
Right? What if we want to do a pool operation, meaning that my system is now going out and fetching a bunch of files from another location? When you start exploring this, you realize that there's a lot of creativity and innovation and stuff that maybe they even haven't thought about.
All right. So, on my journey to join Ness, I've been learning about some of the thought leaders inside of Ness, and I got to meet Oded Nahum, which has been a lot of fun. We instantly started talking about cloud technologies and different things that he's involved in. What we wanted to do is just do a little jazz session on different ways, modalities and formats that are being used for moving data around in the cloud. Oded, my background comes from contract manufacturing. When I very first, I was very young, I was in charge of getting all the pricing out for quotes. And we adopted this tool called QuoteWin that had EDI transactions, right? So you'd have this EDI to a Avnet or Avro. Yeah, there were a whole bunch of vendors that we would send our bill of materials to, and then they would quote it back to us with this EDI transaction that they had set up in QuoteWin. And I remember when we were on a call with Avnet, they said, we're doing something new. We're moving to something called XML. And I remember oh, wow, that sounds very futuristic.
Well, it kind of shows our age, right? When we start talking about these technology revolutions. Yeah. So, Jack,
totally.
Welcome to Ness.
Thanks.
Yes, indeed, it's been fun, some of the conversations we've had. So I run the cloud team. And again, talking about some weird things in the history. I did start my career actually in the world of networking and telecoms. Mm-hmm. And I was got to see the evolution moving from dial-up to cable modems, right? So,
oh wow,
talk about some wow factors, when people go from whatever it was 14.4K to half a megabit. That was the first version of cable modem, half a megabit, right?
Yeah.
And suddenly you can actually send files and move data, and the speed was blazing, and now it's in my home office, I've got a cable modem of 800 megabit per second, right? So,
right.
Today we think about data it's now and it's immediate, and if it takes more than 3 seconds, everybody get nervous.
Oh yeah, I remember there used to be this software called Alpha World, and I remember it was a 3 megabyte file that I had to download, and they said go get some coffee, because it's going to take you some hours to download this file. So it's just hilarious, how much faster it is. And it's all routers. I mean, at the end of the day, you've got these routers that are just amazing, that are pushing data around. So obviously the core modality, even though protocols have changed in that core modality, it's still the same foundation type.
So I think all of that is probably true. I mean, looking at data, some smart people said that data is what fuels the economy and businesses. And that's very true. I mean, we all need that data either to process things, to make decisions, to understand our business, to understand, the reality around us. And what happened with cloud is that the speed in which technologies evolve and become, available is way, way, way faster than the ability of the companies that ultimately needs to use it and how they can evolve with it. And that created a bit of a gap in how kind of we understand these things. So while these newer technologies, whether it's streaming or APIs or some of the other stuff that allows us to get access to the data in a split second and use it very fast and make decisions based on that data and analytics and AI and machine learning and all that kind of good stuff. There's still kind of a big chunk of the world, right? If you look at some of the businesses that use these systems, they're still living in a different century, right? Their ability to evolve with it is much, much, much slower. And if you look at governments, financial services, healthcare businesses, all of them rely on a massive amount of data to be available. But first of all, they don't necessarily need that data to be available a split second after it got created, wherever it got created. That's one thing. The second thing, their ability to adopt these technologies is very limited. because they're all disruptive in nature. They all forces you to change not just the technology,
Yeah, the whole
model
back
around
end.
it, the operational model, how people interact. Are the skills even available? So that's kind of made its way to some of the technologies that we've been seeing companies use that were invented, 50, 60 years ago, but
Yeah.
are still kind of fueling, big chunk of our business today and how companies still use data. So yes, we have, endless amount of storage and compute capacity running in the cloud, but then we use, very traditional methods of moving data around. SFTP is maybe one of the best examples.
Mhm.
And for me, I mean, I always kind of make a joke that, using these SFTP and file transfers based on SFTP is like it's the Toyota of file movement. It's
Yeah.
not very sexy, but it's
Yeah.
reliable as hell. It always
Yeah.
works. It's very efficient. It's not too expensive to operate, and it's compatible with pretty much everything you can imagine. And that's what makes this thing so interesting for companies, that can still get the data into the cloud, right? So then they can use all the processing capacity and tools for analytics and storage that lives in the cloud without actually changing every possible system that needs to connect to those backend servers, which
So
made
so
that
how are
quite
they how are they using the cloud though? Like, because my background of when people used, say, like an SFTP, it was, like literally like peer to peer. I'm going to just send this file to you. Of course, smaller files. I mean, I remember we had this thing called back when we were doing a lot of SFTP stuff.
FileZilla. You know that? Remember
Yeah,
that
yeah,
one?
yeah, yeah. FileZilla. But it was, if I remember right, I mean, it was pretty like, I'm gonna take a file and drop it here. But in corporate sense, you had like MFT solutions where there would be some kind of
Conceptually,
enterprise application.
conceptually, it didn't change much from the way of how the data is moving. SFTP is a protocol. It's got a server. It's got a client. The
Yeah,
client is the one usually initiating the connection and then says, great, connection is now initiated. By the way, it's fully secured and encrypted, which makes it attractive for companies. Once that connection is established, the client usually pushes the data over to the server. So
yeah,
imagine the server is sitting in the cloud. The client sits wherever they want in the world. It doesn't have to be, usually
yeah.
these are external companies. It's not necessarily the company that owns or runs the environments. And that's really where allow that interoperability between systems and between companies. And
Right.
once that connection is established, you can start pushing files. Now, take that and multiply it by a massive scale. And I'll give you a couple of examples. Payment industry. It's a
Uh-huh.
very large, industry that probably moves the millions of files per day. I'm not kidding, per day, right?
Wow.
These guys, it's not real-time data because a lot of it is for reconciliation and batch
Yeah.
processing. So they have these kind of end-of-day processes where they take all the data from whatever payment processing and gateways, collapse it into a bunch of files, and then they send it over to whatever company that needs to process it, on downstream systems.
Yeah.
And we can easily see companies moving 20,000, 30,000 files per day.
Hmm.
I'm not kidding. So the
And how big
scale
are these
has to be
files?
there. It depends. Some of them can be, in the megabyte sizes, and
Okay.
sometimes if they do aggregation, so they compress multiple files together, it can be in the multi-gigabytes size.
And it's got to be
From
a
the
daily
protocol,
transfer.
yes, these are daily transfer many, many, many
Okay.
times a day.
Hmm.
So that's the first part of that transaction. We made it, first of all, massively scalable, right? Because we've got the internet, everything runs on top of it. It's not real time, so you can schedule it to run at 2 in the morning, and it doesn't matter if it finishes at 2:30 in the morning or at 4 in the morning. It's going to run.
So
And
wait,
it's
is
going
this a solution you guys built?
We've built it for companies, and it's quite common to use these systems. And what we've been seeing with companies, so these technologies existed for a while by many other companies that build these very kind of traditional monolithic, server-based type technologies that you
Yeah.
used to run it in your own data centers, right?
Right. Right.
Um, and these became quite complex to manage. They don't scale very well. Every time you need more capacity, you got to go and buy a piece of hardware and get it into your data center, and obviously there's cost comes with it. So, and if you think about the volume that you need, the volume of data that gets accumulated over time, that means that not only your server technology needs to expand, also the storage that supports that. And it became complex and expensive for companies to manage. And then cloud suddenly offers you that endless capacity and elasticity of resources, which became very interesting. So we started building these systems in the cloud, basically copying the same methods. We have a server that exposes the SFTP protocol to the world, right? And we are allowing connections to come in and basically send files over. So that conceptually didn't change much. What made these things very interesting in the cloud world is the back-end automation that we can do to process these files as they come in. This is where you can start implementing very interesting business logic, right? So a company might say, if a file comes in and it has this naming format, I want you to run this workflow that's going to take this file, rename it, right? Maybe add some metadata to it, like tagging, right? And wait for 3 other files that has a similar name, compress them all together, and then drop it in a completely different storage, system, because now it needs to go into whatever databases or processing or whatnot. Even to a point where we can take file coming in, land on one cloud, and then push them to another cloud. Because maybe your analytics system lives somewhere else, right?
And is that just another SFTP thing, or are you using
we can use that? We can use that. What we've started seeing that once we're actually in the cloud and we've received the data, we can leverage a whole bunch of other things that suddenly are at our disposal, right? So we can use different protocols, we can use APIs, we can use SMB, we can use NFS storage. So the initial thing was give me the files into the cloud. And for that, because this is where I need that interoperability with non-cloud systems, I wanted to go with the protocol that is most common in the industry. And that happens to be SFTP. Everybody uses it. Everybody is aware of it. It passed, it stood, the test of time many times over. It's trusted by the industry. So there's no problem of, oh, my clients don't support my security model, right? It's SFTP. You've been using it forever.
Right. Yeah.
Once the data is in the cloud, suddenly I've got a whole bunch of tools in my toolbox to process that data. By the way, I can then use things like streaming. We've done things where we go from batch, which is really the file movement, to a streaming, meaning we pick up the file and then we can stream it to things like Kafka, Kinesis, other technologies, right? So you suddenly get.
And are you streaming it? Are you streaming it based on a? I'm just trying to think. Like, are you interpreting the file and then streaming it as data? Is that how you're doing that?
So it depends on the data format. If these data are coming in more kind of as a structured data that I can break down and then stream, there's a couple of interesting use cases why I would want to do that. One of them is analytics. Sometimes you want to have an analytics look at kind of a time series of data, right? Even though I would get it as basically a file with a million lines, now I want to stream it so I can see kind of how the data is progressing over time, and I can analyze it on the fly. Obviously, for a real-time decision, it's a bit too late because that data might have been created, yesterday. But this does allow me to do some other stuff with it, like split the data, process it in different ways, store it in other systems, downstream. But so these are a bit more advanced use cases.
It's interesting though, because you're really it's almost like you've mixed the SFTP with sort of these cloud capabilities, and now you have all these like flexible endpoints, and it's very cool.
So, I'll give you another.
So is this like a product?
Example. It's not productized. It's a solution, I would say. It's an architecture that we've built. It uses a lot of the cloud native technologies. We like cloud native. It's a great buzzword, but ultimately, if I break it down into things that make sense, if I'm not moving any data, this thing doesn't cost me anything, which is a great advantage,
All right.
You pay for what you use, right? It can be massively scalable because now I'm getting 20,000 files in the next hour. So I can scale to that point. And once these transfers are finished, the system kind of scaled down to, it doesn't really cost anything. And it's true also for the storage and the processing at the back end.
Okay.
But one thing I wanted to mention about a very common, I would say, integration pattern between file movements and back-end processing is with ETLs. A lot of the ETL work starts with data ingestion, right?
Right.
Meaning I got the data somewhere, now the ETL can pick it up and I can do whatever I do, data engineering on top of it. And for many companies that work with external sources, right? Think about a financial services company that gets data from the Bloombergs of the world, right? This is all external data feeds that's come in. Usually it would get dropped into some sort of a storage in the cloud, and then the ETL would pick it up from there.
Right.
SFTP became that front end that allows these files to come in a very simple and easy way that is supported across the industry. So that's, a very common use case that we're seeing with many companies. So it's not just file transfers. The back-end system that uses that is fully integrated with, the way that these systems work.
So what I'll have to do, I don't know if you have a write-up on this, but I'd love to include that in the, I'll put it in the video description when I publish. Yep. If you have something out there, that's kind of an interesting solution. SFTP's been around a long time, but I haven't heard about people, sort of cloudifying, sort of taking that protocol and turning it in, because it sounds, when you talk about it, it sounds obvious that would be a really cool thing to do if you could, especially once it's in the cloud, all the routes you could take it, all the optionality that you'd have from that point.
Exactly. Yeah.
So
now it's really, we're kind of breaking this down into two kind of things. One, how do I get the data into the cloud? And then what do I do with the data? And there's great flexibilities in both. Another thing that we saw that is very interesting approach in the world of file transfers. Traditionally, the file transfer solutions are based on what we call a push operation, meaning the source is the one initiating the transfer. So if let's say I'm a payment gateway. So, all day long, I'm processing payments. At the end of the day, I do a data dump that creates a file, and now I got to send that file somewhere. That's a push operation. And then clients told us some things. Well, what if we want to do a pull operation? Meaning that my system is now going out and fetching a bunch of files from another location. And that kind of like, okay, this is not necessarily going to be an SFTP, but now we're kind of reversing the order of the data flow.
Yeah.
Which something that we had to kind of think through how we want to do it and what would be the triggers of that. Is that based on the time, based on an event, based on somebody pushing a button? So we've done some interesting logic of what triggers that operation, right? And what does the system needs to know in order to go and get files from somewhere else, right? So think about integrations between multiple systems that might live on completely different clouds, managed by completely different companies, that gives them this very flexible ways of transferring data with one another. Now, one of the things that we wanted to think about that is, if you look at the chain of events that needs to happen across kind of the life cycle of files, right? There's scenarios where we're saying, well, the data is going to come in at 2 in the morning, right? For, end of day batch operation. At 3 in the morning, I want to start my ETL.
Yeah.
But sometimes, it doesn't work because there's a power outage or the internet is slow or whatever reason is.
Right.
And then the operation is starting to fail, right? So we've added these kind of scenarios in which, I'm not going to wait for that. I'm going to go get the files. And only when I finish getting all the data that I need, only then I can start the next step of the processing. So it gave us a bit more control of kind of the end-to-end life cycle of data.
Right.
So that was kind of an interesting thing that we've done that is not necessarily built into the SFTP kind of world, because essentially we're reversing the opposite.
So it's basically they get to create a pull request, but it's using the same protocol types, I would assume.
Well, that's now going to depend on whoever has these files. They would now
Right.
expose the interface to me.
Okay. Okay.
And if they have SFTP, I can use FTP. But some of them, for example, would do an API. Says, no,
Got
no,
it.
if the data is there, now I basically trigger an API, says, go grab me that data, right?
Okay.
So again, the flexibility here is broad, right? It really allows us to interoperate with multiple systems, multiple companies. And another thing that became both a challenge, but also the opportunity for innovation is authentication between systems.
Mm-hmm.
That kind of a decoupled architecture gave us pretty interesting ways of understanding how every actor in that data
Mm-hmm.
movement maintains their own security standards, but still operate with one another, right? Because essentially, if I want another company to interact with systems that I run, I have to give them some sort of access.
Right. Right.
And now we have ways of doing that in a way that is very secure to start with. And also, there's a lot of different options. We can use MFAs, we can use rotating passwords, we can enforce security in multiple ways. We can connect to third-party authentication protocols. So it's not even me who controlling that. We can agree on, okay, let's authenticate using Google or whatnot. So
right. So would it be that you're adding a third layer of authentication to it, where you've got the two parties that are in agreement? You're creating a third.
Yeah, and we
party,
use tools like, incognito. So basically, when the system authenticates, it says like, well, the authentication party is actually Google. So I'm going to pass the credentials. And if they tell me you can connect, then I will allow you to connect. So in a way, we're kind of collaborating with that and creating these different structures of security.
Interesting. And does, because my background with managed file transfers really came from pharma. There was a company called, I'm going to botch their name, but it was a company that was supplying doctors data about doctors. It was like mastered data on doctor names, and doctor names are actually awful because father is a doctor, son is a doctor, son's child is a doctor. So just like all these duplicate names and stuff. And so that data was really valuable to pharmaceutical companies, because what they would do is ETL it into like a master data file, where they would use that to, send out to the pharmaceutical reps, like, here's the unique doctors that you need to go visit and things like that. But that company, what they ended up doing is using Snowflake's data share. So what they did is they created a Snowflake instance that shares the data between. This is something interesting that Snowflake's been doing over the last, it's probably been, it's been since the early years of Snowflake. So this is probably almost 6 years that Snowflake's been doing this. They created this concept called data sharing. So the way they're sharing is the entire structure of their data sharing. It's not a movement structure. It's a access control structure.
Mm-hmm. Yeah.
So what they do is they basically allow you to create these like very ornate access control methods that allow for third parties to access, sort of views of data. But what it's done is it's made it so that they have like this, it's a pretty elegant solution where you can share data without actually moving it. And it allows you to sort of have this view of data, but the restriction being that it is Snowflake. Like, you have to live in Snowflake. So, but I wonder, like, if you could do some mixing there, because because it's interesting just to have this option to be able to kind of push data to anywhere you want through an SFTP protocol.
One of the ways that we are kind of evaluating these use cases is the understanding of where is the data being generated, and where does it need to be stored or processed, right? In very centralized systems, everything gets generated and stored and processed, centrally. And then you have consumers of that data, which I think this is kind of closer to the model that you described. And then you can use a lot of things like APIs, which allow you to then, access the data from a browser and stuff like that, or some other, automated tools. I think where we see especially the industries that use those systems, the data gets generated in a decentralized way. And in many times, it's coming from other companies that not necessarily would have a relationship or a working relationship with the person who needs to get the data and process it. I think that healthcare is actually one of those scenarios.
Yeah,
Not only
sure.
that, for healthcare, the type of data they generate, these are not text files. Sometimes these are massive imaging, right? So you need to need big data, and then you need to store it somewhere, right? And so this is where, now I'm not saying you cannot do it in other ways. It comes down to the efficiency and the cost and, you know, the interoperability. Yes, we can move everything to be API driven and streaming based technologies, but the cost on creating some of the interoperability with legacy system that lives at the edges of the internet that generates these data, cost is enormous, right? Imagine that suddenly every credit card payment gateway needs to be internet connected, you know, Kafka producer, right?
Yeah.
In many ways, it's just not worth it.
And I can totally see, especially images. Like, I don't even think there is another way to do this without, when you have images, like how else would you do it? I mean, I don't even know. Is there a way to do it outside of
no, you
like
have to transfer the file in it's the format, and it's not just graphical format. It's very unique to the devices themselves, right? So which devices might have this, and you know, whoever else makes these like imaging devices might have a different format, and you need to have a very, so these are things that are very tricky to move.
Yeah.
I can tell you just another interesting use case from the world of healthcare is lab management. That's another, it's a big world of data movement, you know. How do you take samples from the labs? How do you process them? Everything ultimately gets stored, and you have companies that service hundreds or thousands of different labs around the world, right? All of them produces data all the time. And that data is all being centralized and sent and stored and processed. So that's data that the lab produces. Then you have another set of data which talks about the lab equipment. Is it calibrated? You know, all of these other like supporting processes. So these are some of the use cases where the type of data that's being processed is unique. The privacy and security around it is super, super important. And you have to follow all these standards and regulations, which are not only strict on their own, they're also regionalized. So you might have a system that needs to serve different security and compliance protocols depending on where the data is coming from. And that's another thing that cloud can do very, very well. For example, you can identify where the connection is coming from and apply a set of policies that are the right for the region or the country that where the data was generated. So you can actually look at the entire data governance model, you know, following kind of these constructs.
You know, this reminds me actually of a solution that we built several years back. It ended up getting used by one of the largest not-for-profits. It's a large organization that sells of girls that sell cookies every once in a while. Anyway, anyhow, their challenge was that, and it's not just them. There's a healthcare scenario as well that we implemented this at, but the challenge is you have many endpoints all sharing data to a central, you know, location. And the data that these folks are sharing is typically, you know, Excel spreadsheets. So they're, you know, creating their Excel spreadsheets, making edits. But ultimately all that data has to roll into one aggregated presentation of what the data is across all the organizations. So there's no application that's driving this. It's all spreadsheets. To give you another scenarios, one of them was a healthcare organization that does surveys. So the patients would fill out surveys, and this information would all get pulled in. It included, you know, sort of stuff with the HL7 interface and stuff like that we had to like include. And surprisingly, HL7 is a standard that, like, it's a standard, but hardly anybody follows the letter of the law in the standard, right? So you get this nonsense that's in the HL7 file, and they'll always give these excuses why they put it that way. And so what this little application we built allowed us to do was to send a message back to the people that were sending the file, what errors were in the file. So basically, we had a standard for what the data had to be, and if they didn't meet that standard, we would create a message that would say, this, either this cell or this file or whatever you sent us does not match the standard that we have. Here is the standard. Go fix your file. And we did this because centrally it was nearly impossible for them to deal with all of the permutations of how they were screwing up the data. So they decided to decentralize that into the people that were actually submitting the data. It kind of rings that, there might be some mixing that we could do between what you're doing and what we've done.
And, I think so. The kind of the pattern that comes to mind about when I think about this is what we call an event-driven architecture. Right? Mm-hmm. Now, it's used across many systems in the cloud, but I think specifically for moving data around, it's what makes these systems very interesting, because every event, whether it's data coming in or data coming in this format, or data coming in and ended up in this location, or think of any other scenario that is being understood by the system as an event, can trigger an operation, which allows us to create very creative business logic, right? Mm-hmm. You talk about failure scenarios. That's a no-brainer. Of course, if we have a business logic, what we call workflows, a file coming in and we're supposed to take this file, compress it, and move it to another folder. And for some reason, that operation failed, right? This is an event that we can process and do all kinds of stuff with it. One, we can notify the sender, hey, or we can notify the sender, say, if you want to resend, click here. That click here might trigger something that says, okay, now I'm going to resend that file. Or, all these kind of scenarios or for example, if we do validation on the data, we can say it failed because the validation failed, because you send us, pictures of your wedding instead of that, transaction file that we were looking for. That kind of stuff. All of these business logic can be implemented. And what we've been doing with companies is really trying to mimic their ways of thinking about it, right? Mm-hmm. When you start exploring this, you realize that there's a lot of creativity and innovation and stuff that maybe they even haven't thought about, right? Because they're coming in from, I just got to move this file from point A to point B. It's like, wait, we're going to do this. Let's be creative. Can we do more stuff with it, right? And that kind of opens the door to things like, enriching the data, processing the data, saving it in different places, building dashboards that gives you a view of how your system is behaving and how fast, you can do it, and where can you save some money on, bandwidth cost and stuff like that. So,
right. I mean, if you can maybe, once it's in the cloud, make it sort of, make it sort of the window to the data so that you don't have to transfer that data yet again. When it comes to costs are you having to pay for outbound, inbound costs when you're moving data like this?
Typically, you don't pay for inbound. So that's kind of the hyperscalers. Hey, give me all your data for free. Of course, when you get it out, you're going to pay.
When you FTP it out, do they charge you for it?
But that depends on which network it runs through. If you're going to use the public internet, then it's probably the most expensive. If you're going to send it to another cloud location that you own, let's say you're running an AWS and you send it from region 1 to region 2, you still pay, but it's reduced. And so there's multiple ways of looking at this, but typically you pay for the outbound traffic, not the inbound.
Now, does this cause any friction when you're pitching it to somebody in terms of like, why wouldn't I just do a point-to-point FTP or SFTP to them? I don't know how much that ends up costing. So
we're going to have a whole episode talk about cost optimization in the cloud, but yes, cost is always a thing that we need to look out for. And typically what we do is we provide our clients with as detailed and as accurate as we can view on the projected cost, not just for today, but how that's going to grow. Meaning,
Okay.
if you move data at a certain rate based on these estimations, and your storage cost increases, and so we can provide these quite detailed views of, okay, how this thing is going to look like 3 years from now, in a month by month kind of a trajectory. Typically, if I compare this to running these systems in your own data center, the ROI is incredible, right?
Oh yeah.
Because to give you an example, I mean, a big size company that has traditional file transfer solutions would run this anywhere from 10 to 20 different servers, right? These are traditional machines that runs on a piece of hardware with an operating system that they manage and control. And there's a team of 6 people managing that.
When I first got into the data space, I had, we were working with a concrete company, and we were doing their data work, and I couldn't figure out, like, why are they freaking out about the server costs related to their ETL tool? I'm like, I'm not understanding. Like, I can buy a machine that is like so cheap. I'm like, I don't understand. Like, I bought a machine for $1,000. I'm like, guys, you're an enterprise. It's like $1,000. He's like, Jared, no, you don't understand. Have you ever tried to buy enterprise hardware? I'm like, well, no. I mean, I bought I have a computer. I mean, I can buy a new hard drive. He said, Jared, the hard drive that you buy is not enterprise grade. If you want an enterprise grade hard drive, you're going to pay $14,000. That's like RAID set of, and I was like, what? And so if you actually go into enterprise hardware, it's ridiculously expensive. It's not just kind of expensive.
I mean, it's an upfront investment for things that you still don't know how you're going to use. So, and when they buy these servers, by the way, they buy them usually very big, because they don't want to buy 20 small ones. They rather buy 4 big ones. So $200,000 for a piece of hardware that probably in its first year of life, it's going to be used at 10%. But you've already paid for all of that capacity.
In the old terms, we used to call it, you have to build the church for Easter Sunday.
Exactly. Yeah.
So you have to build this huge server that you'll never use for capacity.
And I mean, the cloud, from the very, very early days of cloud, that was the one thing that it was challenging, right? This idea that you don't build the capacity for your peak usage, you build it to be elastic, meaning it needs to scale up and down with your demand. And, it evolves in what we call value optimization for cloud. It means that whatever you spend needs to align with the business value that you're getting out of it. And business value can be understood in multiple ways. It could be the cost of running systems on-prem. It could be how innovative you are, release cycle, velocity of development, all that kind of intangible, values of cloud. But we want to understand the cost of systems in relationship to the value that they drive. It's not a trivial exercise at all for companies. And I think lately, if you look at some of the, analyst report we're getting about cloud, especially in the last year, security was always the number one concern. Now security is number 2, and cost is the number 1 concern for most of the CIOs. And that kind of opens the door to a lot of these conversations. And by the way, I think one of the adoption trends we are seeing specifically for the MFT is from cost, because retiring these older systems that are expensive to own and manage and license, and building something that is very lightweight and dynamic and can scale easy and fast, is the ROI is very strong on that.
Also, there are so many tools in the cloud now that, like, once it's in there, you've got so many routes you could take it from that point. Which it seems to be an obvious. I mean, I hadn't thought a lot about, how MFT might, play with just sort of the standard MFT process might play in the cloud, but I can see it being, highly valuable. I mean, even if it's images, you need a place to put those. You got a place to process those. If you're using AI to figure out what's in those images or things like that, it's all processing that'll happen ideally in the cloud. So it makes a lot of sense.
That's very true.
I am really curious what the cost structure looks like when the outbound stuff happens. Because usually in the MFT, I'm curious like what that ends up looking like for customers. But the nice part is you pay for what you use. You know, you're not paying for stuff up front that you don't have real unrealized value for.
True,
So,
and when we do see these scenarios, what we would try to do is then figure out, can we do some processing, aggregation, compression, and whatnot on the data before we send it out, right? So
yeah.
wherever the downstream system is, it's going to get only the data that it needs, right? So that can help us control the cost.
That's interesting. Right? That's interesting.
If you just
you've got a lot of
looking at this, well, I'm getting in 100 megabyte, and I'm sending 100 megabyte without any processing, then you might as well send the data directly to your downstream system without any business logic. It kind of beats the purpose of the system. Which really, when I kind of talk about MFT and we work with clients on building this, I really want to get them to think beyond the basic SFTP protocol, which is client server, move file from one side to the other. Yes, it's there and it's a big part of the system, but the real value comes when we build the business logic, the automation, the processing of the data at the back end, right? That's really where they get the value of the systems.
Now, are you replacing older systems? Is that what you're mostly doing? Or are you just taking on new projects like, hey, we got this new project that we're doing. Oh, let's use this.
In the cases where we're building ETLs, usually we would recommend, if the data sources are external to the cloud, meaning you are not generating your own data, right? We would recommend to put the SFTP at the front end, so you can get the data from outside sources, and it's very secure and easy for us to manage.
Okay.
So that's one use case. Now, if in other use cases where the client has one of the many traditional, monolithic systems already in place, we would then replace it. It's not even, we don't even call it migration, because we're not migrating anything. We're rebuilding the functionality. In some cases, we would migrate the business logic that they have created. So they have some stuff we want to, take these files and copy them and compress them and uncompress them and, rename them or whatever they're doing, or do virus scanning on them. So we are rebuilding that functionality in the cloud.
Okay. Interesting. Well, listen, Oded, this was really cool. The conversation went a direction I wasn't prepared for, but I want to. I think this is really cool. It's a thing that I haven't given a lot of thought to in terms of just how SFTP could be enabled further using cloud. So if there is some kind of white paper about it, I'd love to include it in the video description. We'll do some more of these. We'll go over different solutions your team's produced. Yeah, and then folks, if you guys have questions for Oded, drop them into the video description or the commentary. And if there's questions or whatnot that you want to talk with him live about, just go to the Talk with a Specialist portion on the Ness site. We should have a page for that, and we can get you all in touch. So, Oded, thank you so much. It was great talking with you today.
Yes, thank you, Jared.
All right, have a good one. Take care. Yes.